So what we're going to do today is talk about relative error, and it's often the case that the measurement of the length of an object is not equal to the actual or the exact length of an object. Therefore, we need to understand the absolute error in measurement and the relative error in measurement. So basically what we were saying in class is that if I measure something and then you guys all measure that same thing, most likely we're not all going to get the same answer. So there's something that's called an absolute error. And the absolute error is the absolute value of the actual value minus the measured value. And then we said, well, essentially when you're measuring things, the distance always has to be positive. You can just always say, as a rule, that the absolute error is just going to be the big value minus the small value. Okay, because the absolute value of big minus small is the same thing as the absolute value of small minus big. So I wouldn't worry so much about the absolute value piece of it. I would just say always do big minus small. That's going to be your absolute error. The relative error is just that big minus small divided by the actual. And that's where it's really important that the actual value is what you get on the bottom. So why don't you go ahead and just cross this part out. And let's do some actual problems here. So if in example 1, the measured length of a segment is 4.13 and the actual length of the segment is 4.15, what is the absolute error and the relative error? And you're going to round answers when possible or when necessary to the nearest thousandth. So the absolute error, we're going to do big minus small. 4.15 minus 4.13, and that comes out to be 0.02. When we find now the relative error, we're going to take the absolute error, the big minus small, and we're going to divide it by the actual. The actual happens to be 4.15. When you divide this out and you round this to the nearest thousandth, 3 decimal places, that's the answer that you get. Okay, take a look at the second example. A groundskeeper is replacing the turf on a football field. Turf is the actual area covering the football field. His measurements of the field are 103 by 60. The actual measurements are 120 by 54. Find the relative error in the measurement. And we're dealing again, because we're replacing the turf, we're dealing with area. That you need to know. It didn't come out right and say it, but you need to understand that that's what they're talking about. So what happens is I've got this guy measuring at 103 by 60. The actual happens to be 120 by 54. This is the one I'm going to start because that's the actual. When we find the areas of each, the area of what's in blue happens to be 6180. The area of what's in red, the actual area, happens to be 6480. So what we're going to do to find the relative error, we're going to take big 6480 minus small 6180, and we're going to divide that by actual, which we've already agreed was the red, or 6480. When you do this on the calculator, if you're doing it all in one step, you need to use parentheses around your numerator. What comes down to the nearest thousandth, 3 decimal places, is 0.46. Next example, the edges of a cube are 4.2 inches. Jenny measures the edges of that cube to be 4 inches. What's the relative error of the volume? So they actually tell you what you're looking for. So instead of drawing a cube, I'm just going to draw like the corner part of it. And I'm going to realize that a cube has a length and a width and a height. And the fact that it's a cube, all the faces are square, so all the sides are the same. All the edges are the same. So this particular cube has length of 4.2, width of 4.2, and height of 4.2. Jenny measures 4 by 4 by 4. We know we're talking about volume. Volume of cubes, they do not give this to you in their regions, is length times width times height. So the volume of what I have in blue, when I multiply everything out, gives me 74.088. The volume in red gives me 64. Well, the actual this time we know happens to be what's in blue. All right, Jenny did the measures. The measures are what's in red. So now when I do big minus small divided by actual, I'm going to say my relative error, not color coding it this time, would be 74.088 minus 64. in parentheses, divided by the actual. And then the relative error to the nearest thousandth comes out to be 0.136. Okay, so that's it. So you should be just fine on the homework. Good luck.